All right, hello. This is chapter 5, video number 5, our last video. So we have been talking about different probability rules. We did the general probability models. We talked about addition rules. We did multiplication rules. We discussed conditional probability and independence. And the last thing that I want to talk about is um, probabilities without replacement. So this is going to be probabilities without replacement. So here is the setup. My son is a fourth grader, and he has a place in the his classroom's library where he's able to go and pick a mystery book. You're allowed to pick a book. You don't know what it's going to be, but that is the book that you're going to read. And let's say that there are 10 different books in his mystery book selection. He's got 4 historical fictions in there. He's got 3 science fictions, 2 nonfictions, and 1 poetry. And I haven't seen it. I haven't seen his classroom. But let's say that they're just all in a bag. You can't tell what you're selecting. I want to figure out what is the probability. His favorite type of book is historical fiction. He loves the I Survived series. He loves historical fiction. I want to figure out what is the probability that he selects 2 historical fiction books. All right, now you might be saying, oh, come on, this is so easy. We've already done problems like this. Well, there's something a little bit different about this problem. So we do have 2 events, and you guys are probably kind of thinking, okay, well, multiplication rule. We have 2 events going on. We have the first book that he selects, and we have the second book that he selects. But we are going to have to be a little bit careful with this. So first off, with the first book that he selects, this is going to be an easy probability. First book that he selects, we have 4 out of 10 books that are historical fiction. 4 out of 10. Awesome. Oh, I guess that messes up my lines a little bit, but 4 out of 10, probability of getting a historical fiction book on the first try is 4 out of 10. However, something changes with this next probability. His teacher is nice, but she's not going to allow him to get credit for reading the exact same book 2 times in a row. So a few things have changed. As soon as he has selected this historical fiction book, one of those is out the window. All right, and there are only 3 of the historical fiction books that are left on the shelf for him to select. So instead of out 4 possible historical fiction books, he is now down to just 3. Wah wah. But something else has changed as well. There are no longer 10 books here. There are only 9 books here. So this probability without replacement, we didn't get to put the historical fiction book back in there. Things changed. First off, we went from 4 to 3, and instead of 10 books total, there are only 9 books. So multiplying this across, we do have 12 out of 90. And if we divide this, the probability that he gets to read 2 of his favorite types of books is 0.1333333, about 13%. So this is selection without replacement, and we didn't have to worry about it in these previous problems. With this multiplication rule, this would be assumed to be a very, very large high school. 25% of them are freshmen, 60% are extracurricular. We're not selecting something and taking them out. We're just multiplying those 2 events. Same thing here. We're not if this basketball player makes 80%, we don't have to adjust this probability. Those are independent events. But these aren't independent events. As soon as you make your first selection, that does affect your second selection. So this probability needs to be adjusted.